In Cubes, we would like to have some secure option to allow untrusted VMs to use accelerated graphics. It's both for computing, but also for displaying stuff. And currently, the only kind of sensible option that exists in practice is having separate GPU per VM per domain you want to use it in, which is not really scalable and also not very reliable, especially if the GPU has some persistent firmware storage, because then you cannot really safely reuse that GPU for anything else. So that's the basic background what this is all about. And Demi has a few ideas and some summary what can be done today and what can be done in the future, and yeah, some starting point for the discussion. Okay, Demi, are you there already?
I was wondering, did you explore Virtio GPU like Virgil? As we spoke about Virtio yesterday.
Kind of. My understanding is it's on the emulation needed there on the trusted side, like on the host side, is quite complex, which I would really like to avoid, because complex stuff has bugs. But yes, that's one of the options that may be a starting point for some future improvements.
I'm not entirely sure you can do graphic virtualization without something that is simple. You might be able to switch GPU context, but from what I remember in Zen Client, it was a real nightmare to do it.
Yeah, the reality is that sharing graphics is hard. Even a decade after the attempts from Zen Client, you've still only got two vendors who actually have a sharing solution. There's Intel with GBT G, and to a first approximation that does work. There's a lot of overhead. There's a lot of heavy lifting in DOM 0 to make it work, but to a first approximation, it does work, and it is allegedly secure. I say that without necessarily trusting the massive extension to the i9-15 driver to make it work, but it certainly gets you to a position where multiple VMs can have accelerated graphics, and there is an attempt to lock things down slightly in the graphics card. NVIDIA also have another one of those. It is only available on the data center cards. I don't think it's available on any of the client cards. Newer graphics cards from all three vendors are actually switching to SRIOV as a model for sharing, rather than attempting to share what is one single PCI device. So in that case,
Andy,
yep.
I was just going to mention that on the NVIDIA cards, somebody broke them, so they were able to turn it on consumer grade cards now.
Even better.
Yeah, there's a break that allows you to do it. I think it came out yesterday or earlier this week, at least.
But I suppose in the Cube's case, what you actually care about doing in the common case is using whatever happens to be the integrated graphics card in the laptop or that you're using. Obviously, for desktops, you can choose your own, but laptops, you don't have much of a choice.
Yes, exactly. But also, my impression is that the Intel thing is kind of abandoned, if I remember correctly.
It's not abandoned. They don't care about Zen anymore. But for example, we still have it and we still support it in Zen Server. They're focusing fully on their new architecture, but it does still work.
Okay, so how much work is in practice needed for newer architectures, like whenever new Intel graphics came out?
That is largely down to the a lot of the complexity here is actually in the i9-15 driver in Linux. So it's there and it's open, but that doesn't necessarily mean it's easy to use. I think what they're doing on the KVM side is attempting to standardize on VFIO as a mechanism for dealing with this. So to a certain extent, I think we'd pick up some of the upstream Linux work for free if we actually had VFIO working.
Okay, that does not sound bad, but still, probably maintaining it separately.
I think it would be an interesting thing to try to take the current GBT G code for Zen and try and run it in your graphics VM. Because ultimately you need the driver in charge of the graphics VM to be this huge extension to the i9-15 driver, and with a few bits and pieces behind it. At the moment, there's also some extra work in QEMU to make this work, and it's certainly not an ideal solution, but I think as a first step towards making something, it would be quite good. In particular, what we ended up doing was adding a bit of an extension to it to allow us to pull the guest frame buffers out, because in Zen Center, for example, we want to be able to provide the VNC console. So there's some horrible skanky code somewhere that asks the i9-15 driver to stooge into the emulated state of each of the VMs and pull out a frame buffer. As a result, that's all using the DRM interface. And I assert with absolutely no knowledge whatsoever in this area that you could probably use the same kind of interface to do things like the drawing of colors around windows. So I think you can still, I think it ought to be possible to still be able to do that from what is nominally a trusted, or at least a more trusted entity in the system.
Yeah, that sounds interesting. Actually, there is ideally the actual GPU would be connected to not DOM0 but the GUI domain or whatever.
Yes. So in this case, you do PCI pass through of the graphics card into the GUI domain. The GUI domain probably has to be running the QEMU for each of the VMs using it, because there's some fairly tight sysfs integration there. So yeah, that's not ideal security wise. And you can probably stick some kind of IPC in the middle there.
Sorry.
But as a first experiment, you probably do want. As a first experiment, seeing if you can actually make it function would certainly be an interesting challenge.
Yeah, is it possible to have this QEMU serving only the graphics card and separate QEMU instance for everything else? Like one?
Yes, that's exact. So what we actually do for for the NVIDIA case, we have QEMU running for the regular motherboard bits of it, and we have a separate thing called DEMU. So there's a repo on ZenBits. It's called DEMU, and that's the thing that we link against a load of NVIDIA user space libraries. So in that case, we have a split. QEMU doing most of the stuff that QEMU normally does, and a separate thing doing just the graphics. So this was why we upstreamed the IRX server interface, and why we did bits and pieces like that. So yes, a split device model like that is specifically something we do, and we upstreamed the work for. In this case, in Zen Server, we run them both in DOM0, but there is no inherent requirement to do so, and it really ought to just work when both of those run in different systems. Of course, trying to get QEMU to conform to this model might be a bit more tricky because you've got to cut a lot of stuff out of it, but it should be doable.
It's possible. I did it during my internship a long time ago with hacking a bit QEMU. The new QEMU would be easier than the QEMU trads, definitely.
So I guess the first off, sorry for the technical issues on my end. I had a kernel panic at just the wrong time. But anyway, so I guess my thought was the reason, the whole is the idea that I mentioned, is that actually viable? The whole idea of a minimal secure graphics stack?
Well,
Hello?
it depends what you mean by minimal and secure. To a first approximation, you're bound by what hardware can do.
So minimal, so secure means so secure in this context means that okay, so secure in this context means that it provides the obvious security properties, not at least as far as integrity and confidentiality. And I get, and the idea is to use hardware page tables for isolation.
Right, but where are those page tables?
GPU.
So one of the challenges, and graphics cards have page tables themselves because everyone runs graphics stacks from user space typically. So the GPU does have page tables, but they're only as good as the implementation in the GPU. There is nothing you can run in software that will mitigate a bug whereby one bit of the command stream can accidentally write over a different bit of the command stream and things like that. So
do those bugs actually exist?
Yes. It's taken the vendors quite a long time to think they've taken them out. So the way GBT G works is it actually causes the guest kernel to write a command queue, which it then takes, emulates certain operations and shadows certain other operations because they're aware in that particular architecture that there is no isolation in the card itself. They rely on software auditing of the command queue to gain the isolation properties that you want. Of course, newer versions with proper SRIOV built in are supposed to have hardware guarantees in there. But my point is that fundamentally there is a point at which you have to rely on the GPU to do what it has been told. And there are some things you can control on the software side, but if there is a bug in the GPU, there is a bug in the GPU. So I don't think it is going to be the case that you can write some software and guarantee that the result is going to be a secure system. The best you can do is write some software to try and do the best it can, and have to rely on the hardware not malfunctioning. And the thing is, even that... Oh. I presume that was another kernel panic.
Yeah. And I guess...
I presume what we're looking for here is real... So from Cube's point of view, what do the users actually need?
So there are two similar cases. One is about just having a graphical interface working smoothly, which is if your VM is doing some rendering, then it currently is software only. So, for example, playing some videos in 4K is not going to work with really powerful CPU. And this is actually the case I have with my laptop. If I open even this very conference in a bigger window, my laptop is going very hot, and audio stops working because it's overheating. So that's one thing. And this, in more extreme case, is also about gaming. But the other case is about just computing, of people doing some computing on GPU from inside the VM. And I think that we more care about the graphics acceleration, like rendering.
Yeah.
It's where possibly, sorry to bring that back again in the subject, is where possibly I think Virgil might be something good, because are meant to support graphic acceleration. I know that in the past people have been looking at doing like a power virtualized driver for OpenGL. So you send the command of OpenGL to the backend, and then the backend will send it directly to the graphic card, making things a bit better than what we have today. It's also meant that it's... Yeah,
so Virgil, as far as I understand the architecture, is basically there to essentially pass through the OpenGL shader stream in a way that isn't too terrible. Now, I have no idea what the internals of that look like from an isolation point of view. Clearly, because of the way it's been done, you can get the VM rendering to a window in the host. The example was done for KVM, but of course the same applies to the GUI VM here. Now, that at least at a first level gives you something that looks like the ability to do OpenGL acceleration. I have no idea what the security properties are like. Again, given that everything is passing through the single GUI VM, you probably do have an option to apply the window coloring in a way that is outside of the control of the VM. but how multiple contexts interact within the GPU is unknown. In particular, I would worry that there might be ways for anyone with a GL connection to be able to read the frame buffer, for example, and screen scrape.
Yeah, that sounds bad, but also I'm worried about approach that includes parsing OpenGL level commands, because that sounds quite easy to miss something, and like you said, either allow access to something that should not be allowed, or maybe even modify.
So something to bear in mind is that outside of the use case we're discussing here, in a general native system, you have multiple different user space processes wanting to do various bits of graphics with the screen. And a lot of the stack is in user space. So even at that level, there is believed to be some isolation between individual user contexts, and that will definitely be at the point of parsing an OpenGL stream. So I would expect that. There is some expectation of isolation between streams at that point.
Is it a reasonable expectation? Because if you are running two applications in the same system, in the same VM, but or without any hypervisor at all, at the same user with the same privileges, I think your expectation about isolation between them are much lower than in case of two separate untrusted VMs.
So I think what needs to take a step back here. So, as Andy pointed out, GPUs are not a trustworthy mechanism, and when you sit there and take an untrustworthy mechanism, and you sit there and say, well, I want to put some trustworthy around this, the only way we're going to be able to do it is in software. And even then, it's only going to be a first order of approximation, as Andy loves to say. You're not going to be able to drive better controls over the GPU, because at the end of the day, as soon as you let one device, one VM talk to the GPU, there are lots of bad things it can do, including screen scraping and all these other things. You're just not going to close those paths off completely. So what we can do is, instead of completely just dismissing Virgil because of its implementation, strengthen the implementation to provide the isolation as best as we can, and understand that at the end of the day, the weakest part of this chain is going to be the GPU. And if there's something that we cannot filter out, there's just no way we can filter it out. If an operation is necessary for the VM to access the GPU, you're not going to be able to do that, because then you'll just literally break the end user and what they're trying to and the usage of the GPU.
So, I'm not a graphics expert in the slightest. I don't know what capabilities an OpenGL stream has. It might be the case that that if all the logical context belong to the GUI VM, and all it's providing is the raster data and the shaders for rendering within the viewport, then that might actually be okay. Obviously, you're going to have resource problems. Something is going to have to sit there and work out and arbitrate who gets to use what percentage of the graphics RAM. and things like that. But I would have thought that that's something that Virgil already does to a first order approximation.
Right. That's a lot of the work that they had to deal with and building it up.
I certainly think it would be interesting to talk to those people and see what their views are on this matter. Fundamentally, they are much more, they're experts in graphics, whereas we are not.
Yes.
So it might be the case that they turn around and say, yes, it's all open, or they might turn around and say, no, we had that, look at what we're trying to do to work on it.
So the conclusion I've gotten from all this is that is that we can't rely on the hardware. We have to do everything in software, and therefore the attack surface is going to be enormous. Is that basically accurate?
It completely depends where you sit in the stack. If you limit the VM enough, then it probably can't do any unmediated things. But
define limit.
Well, I don't know. As we said, none of us here are sufficient experts in graphics to sensibly answer this question.
Okay.
I know it is certainly the case that a lot of graphics cards at the moment in systems basically have no internal security because they were designed with the mind of a single device driver doing it. But they were designed to have multiple user contexts within a single system. So I would like to expect that there is a bit of an expectation there that there's some isolation available.
Yeah,
I wouldn't lever to say it's isolation, just some separation.
Yeah, okay, separation. Because I'm looking at a cube's point of view. What you need is to be able to provide graphics acceleration, which means you need OpenGL or DirectX or Vulkan or whatever the new version is. That is fundamentally what you need to provide to the VMs. Obviously, you can't have each of them driving the graphics card directly because that will result in them getting sad. So the GUI VM is going to have to be the thing actually driving the GPU, taking input from each of the VMs who are trying to render a window or two in the system. Virgil does allegedly give you that control. Obviously, we don't know what the security properties of it are. But at that point in your system, it is the driver in the GUI domain which is actually in control of the hardware. It's not a totally arbitrary driver in the untrusted VM.
So I guess the question then becomes, how big does that driver have to be, and how complex? Like, how low can we get the attack surface?
I don't know.
Okay, so this is a question for the Virgil developers.
Yeah, you're going to have to talk to a GPU developer who understands what each call can be done to the GPU and what's the effects. Can you read back buffers and all this? And then you're only going to get what's intended behaviors as opposed to finding an attacker who's gone off and found what the unintended behaviors are that you can achieve.
Has anyone tried to actually, I guess, has anyone tried to do from an attacker's perspective? Like, has anyone? I know because
So I know of one research paper done a couple of years ago that they demonstrated. They were more focused on the fact that you can hide untrusted code inside of a GPU. That was done by Carnegie Mellon, I believe. Scilabs. You go look at some of the. If you, I'm pretty sure you can just do Scilab GPU vulnerability.
Yeah.
You might find it.
Yeah, and I know there was an Android issue not too long ago involving the Adreno GPU.
Does anyone is using Virgil in production with untrusted guests? Either Zen or KVM. I guess KVM more.
I'm not aware of anyone using Virgil in the Zen community, but then again, we discover a lot of things that aren't known to the upstream developers. Clearly, it was put together for KVM originally, and it's big enough to be taking up the full time of at least one Red Hat developer. So I presume there are people using it.
Yeah.
Good.
That
would be interesting to know what are the specific requirements of the actual user of that code, because then we can maybe reason about what it can be used and what it cannot be used for.
Well, yeah, as I said, the first thing to do is to talk to them, because they will know where the boundaries lie.
Okay, because from my perspective, when it the fact that you don't see any public clouds offering Virgil is a bad sign. It implies to me that it's not intended for hostile multi-tenancy.
Well, the
way you do that is that you never have multi-tenancy when any hardware is involved, even in the public clouds.
Yeah, and not only that, but the public clouds are going to be will have the budgets to go get the high-end GPU cards that provide the hardware virtualization.
Yeah, but even from what I can tell on,
but bear in mind that graphics in a server is very different to graphics in a client device. Graphics in a server, it's all about either the straight up compute, at which point fine, there's no graphics out of the end of it, or it's to do with rendering graphics and then throwing it over the network. So, for example, what you can do with the NVIDIA cards is have the NVIDIA cards automatically encode an H.264 stream and dump it in memory, even with TCP headers on it in one case. So the graphics cards for servers are optimized for throwing the result out over the network. There's no use going and plugging a screen into a data center if you're trying to do this.
Yeah, that's why you have those specifically dedicated cards for PCI over IP that are doing that thing for you.
But typically when it comes to any use of GPU in the cloud, you're talking single tenant per server anyway.
At least how do they protect against persistent firmware threats? Like someone trying to inject malware into the GPU firmware and then...
That's complicated.
Yeah, I was going to say, I think every vendor has their own approach to dealing with that.
So, some work better than others.
Yes.
Are there any that you can recommend?
Probably not going to answer that.
I was going to say, I don't know if there's any you can even get your hands on. I mean, the closest you can get to some of those ideas is going and looking at hyperconverged infrastructure and looking at some of those approaches.
Okay. But any consumer GPU is gonna fail.
Well, again, per the recent NVIDIA hack that was released, that allows you to take a commercial grade card and use their virtual GPU capability. Most commercial cards are not designed with the secure virtual approach in mind.
Yeah. Okay, so looks like it looks like nobody does. It looks like, I guess the conclusions I've drawn here are, this is going to be, whatever this is going to be completely like new territory, so to speak, in the sense that
certainly as far as trying to do it as an upstream project, fully open source, yes, you are broaching new territory here. I know there are a couple of examples who have experimented with it before, and GBT G was designed with a use case a little bit like this in mind. That's not to say necessarily that it's perfect. But the reality is there's far more money in graphics in servers. The graphics in servers now is dwarfing even the client gamer market. That's where all the money is. So the reality is, whatever you're doing here, you will likely be broaching new ground.
Is there any way? Go ahead.
I guess the important thing to realize is that it's very unlikely you're going to find enough details about a single GPU to possibly make something that you would consider perfectly secure. The real question comes as to whether it is possible to do something that is better than the status quo, that people are happy with. The reality is, so long as you make people aware of the risks and let them take an educated decision, some of them will be happy to say, yeah, okay, I trust my gaming VM perhaps more than I trust my random web browser VM. So maybe in the end you expose GPU acceleration to a subset of the VMs and you mitigate some of the risk that way. I think there would still be a lot of people who would be excited at a restricted option like that than to have no acceleration at all.
So it looks like, it sounds like the details needed to actually do this right are all proprietary to the vendors, and there's no getting to them.
Well, the Intel stuff's all public on 01.org, but it's a huge set of register spec sheets. It's not a how do I get to grips with the internal of an Intel GPU. So it's not necessarily the case that it's all proprietary, but certainly a lot of the expertise you would need is probably limited to a small set of individuals. Exactly the same as with hypervisor development, to be honest.
Is there any chance that we could get enough of those people who have that kind of expertise to make this a viable project?
Well, let me ask, I said, go and talk to the Virgil people to begin with, because they look as if they are the closest to trying to do what you're attempting to do. Actually sit and have a real conversation with them and figure out what boundaries exist, if any, and maybe what might need changing.
More of the community question. Is OpenXT interested in this feature also, or is it out of scope for the OpenXT?
No, it's definitely within scope for OpenXT. Not that I speak for the whole community, but at least a portion of it would be of interest. Yes.
Okay.
Would anyone from that side be willing / able to fund development if this turns out to be possible?
Unfortunately, that's a complicated question. I can't answer that one just offhand like that.
Okay, valid.
Okay.
It's certainly my impression that within OpenXT, a lot more of the development gets done via contract for a specific end goal. So if you can turn around and persuade a big company that they want secure shared graphics, then you might get a whole lot of money poured into it. And if not, then not.
Okay. I think we are running out of time here. So thank you all for the discussion.
Thank you, and sorry for the technical issues on my end. Yeah. Thank you so much.
No worries. Thanks, everybody.